I was like, I knew it. Okay, I knew it. Now, this process of homeostasis seems like it would be something relatively easy for the body to do. It's not. All right, we affect it in many ways. And it's going to work by two types of feedback. We're going to see that we have positive and negative feedback. For the most part, positive is bad. It's going to lead, there's 2 or 3 times that positive feedback is beneficial. For the most part, the body maintains homeostasis with negative feedback. Temperature goes up, something happens, we sweat, temperature comes back down. Temperature goes down, that cardiovascular system pulls the heat back in, temperature goes up. For the most part, it works on negative feedback. I see it, I see it. What's the question?
Oh, no, I'm just trying to picture it.
They usually give the example of a thermostat on a wall. Okay? That's usually the best example, because if you think about like the thermostat on your wall at your home, okay, you set that to a temperature that you feel is comfortable. Say, for example, 68. If it gets below 68, heat comes on. Brings it to 68, takes it up a little bit, heat kicks off, drops back to 68. Your body's doing the same thing. But now it's going to be doing this with so many different mechanisms in your body that it's just mind-blowing. When we talk about how the body is going to do this, the how it does it involves, first of all, we need a receptor. Receptors for our body are going to be something with the nervous system. Okay? Whether that's going to be a nerve ending, a little bulb on a nerve ending, whatever the case might be, it's our nervous system. The nervous system's structure has the ability to pick up something. So if I have a receptor and I'm doing temperature, I have receptors in my body that pick up temperature information. I have receptors that pick up pressure information. I have receptors that pick up pain. I have receptors that pick up my place in space, whether I'm going to fall over or not. Okay, we have to have a receptor. So that tells me, if I have a nerve, okay, think, for example, a little nerve coming up, you know, let's think about like something coming up to our skin to pick up the temperature, okay? Well, that's detecting the information. That information has to be processed, and then I have to get a response. So, if it's picking up the information, we're going to send it to the central nervous system, the brain and the spinal cord. Because in the brain, most part for the brain, but in the spinal cord also, we're going to have areas that monitor everything. And they are termed the control centers. They're monitoring your heart rate, your respiration rate, your blood pressure, the pH of your blood, the oxygen levels, the CO2 levels, the temperature. Do you get, okay, monitoring everything. So we get something detected, we send it to the central nervous system. If we send it to the central nervous system, it creates an effect. Some type of action is carried out. So that means something in my body is an effector. Does that make sense? So if we think about the temperature, for example, the temperature going up affected my heart. Basically, my heart was able to push the blood. Vessels were affected because they dilated and let the heat out. Does that make sense? So, for us to have information, that is a feedback system. A feedback system requires a receptor, a control center, and effector. Temperature, brain, vessels. A stimulus, what the receptor picks up, okay? A stimulus is any deviation from the norm, from the set point. Everything in our body has a set point. Temperature, 98.6. Heartbeat, 60 to 75 at rest. We have a pH that has to maintain, for example, blood, 7.45. All right. We have a respiration rate, probably about 11 to 15 breaths per minute. Everything has a norm, a set point. Anything deviating from that has to be brought back to the norm. Very few times will it happen based on positive. It is, for the most part, it is up to negative feedback to maintain homeostasis of our body. Negative feedback wants to bring the body back to normal conditions. If we think about blood pressure. Now, why should I be concerned about blood pressure? Why should I be concerned if it's too high? Okay, might have a stroke, might have a heart attack.
Too much stress. It's gonna damage your kidneys.
Damage your kidney, putting too much stress on the body.
Too much stress on the heart.
Yeah.
Vessels
Yeah.
might pop.
Vessels. Yeah. Okay. Yeah. All right. You know. Yes. But what level do I want you guys to be thinking of? I want you thinking at the cellular level. For the kidneys, for example, if it is a chronic high blood pressure, it can burst cells in the kidneys. If it's chronic high blood pressure, it can stretch out the heart, make the heart not beat correctly, make muscle cells not work, cardiac cells, I should say, but they're part of the muscle cells. Cardiac cells not function. If the cardiac cell doesn't function, they're going to have a heart attack and that cell never comes back to life. Okay? that make sense? So, should I be concerned if blood pressure is too low?
Yes.
Why?
Because
Use your brain.
There's one term you just used. I want to hear it again.
Perfused.
Perfused. What does that term mean? I love that term.
exchange of gases.
It means the blood is getting to the brain and allowing it to.
The blood's ability to make it to the cell, the extracellular fluid, and make exchanges. Now, more than just gases, but yes, gases are included, but exchanges altogether. Here's the way that the body is going to disperse blood every time your heart beats. Every time your heart beats, feeds the brain first, organs second, everything else after that. This is how your body will handle everything. It will feed the brain first, organs second, and then everything else. Therefore, if it's not making it to the tissues of your big toe, guess what? The big toe is going to die and fall off. Not kidding, joking. But it's going to have to probably be removed. So, doesn't really care about the stuff to the exterior. It's focused on the brain and the core. So, in the case of blood pressure, once again, we've got the ability for information to be detected. In the case of blood pressure, the best place that blood pressure gets picked up are from the baroreceptors in the aorta. The aorta branches directly from the heart. What better place to check blood pressure than where it's actually leaving the heart? Because that is based upon how difficult, how strong is that contraction of the heart to push the blood out. So it can pick up information. If the blood pressure is too high, this control center picks up that information, sends the response to the heart to adjust. If blood pressure is too low, sends the information, heart will need to adjust. Now we'll talk more about that in part 2. But that is pretty much how we're going to work on negative feedback. With negative feedback, like I said, we always have a set point, the norm, all right? Heartbeat, blood pressure, what do they tell us is the norm for blood pressure?
120/80.
That's what they used to tell us. They like for it to be that number at a certain age, but they really like to see something like 110/70, okay? Because the older you get, blood pressure is going to go up because arteries are going to harden. They just can't handle it. It's just going to happen. It's just going to happen. Trust me, I know. Okay? Now, we have the norm. So, let's say that they're going to use the norm of 120/80. If those numbers vary, information will be picked up, it will be sent to the brain, and it will tell the heart, adjust. Now, I'm not going to explain the adjustments right now because we're not at that point, okay? Blood pressure goes down, once again, receptors in the brain, information to the heart, adjust. Whatever you do, keep me within my norm. Keep it in that set point is what it's doing. This is not a static state of our body. Homeostasis doesn't just boom. it is not the same all the time. Homeostasis varies second to second, minute to minute, 365, 366 if it's a leap year. All right? It varies constantly, 24/7. The body, for the most part, adjusts and recovers. For example, exercise. I don't particularly like the term, okay, but I know it's important, okay? In exercise, when we're exercising, what do? What type of effects does it have on our body?